Hello, everyone, wherever you are in the world today. Welcome to this DDN technical webinar. I'm Joel Kaufman, Senior Technical Product Specialist for DDN. And today I'm talking with Kevin Cochran, Chief Marketing Officer of Vultr. And as the topic says on screen, we're going to be discussing how to build scalable foundations for large language models and, frankly, for most any type of AI. Kevin, welcome to the webinar.
Great, so great to be here, Joel. Looking forward to today's webinar and discussion.
Fantastic. So to jump right into this, when we take a look at modern AI, we see that its uses and deployments are spanning an incredible variety of use cases. Everything from financial services to energy, healthcare, research, and even more. And there's a few trends that we've begun to see in the industry. There's been lots of movement for what we think is kind of like this first wave of massive LLM foundation model training that started a couple of years ago when people realized we have to have the best intelligence behind the scenes to this current kind of apex of how to get a RAG pipeline working, right? All this augmented generational work. And now we're seeing this evolution of that into the beginnings of this wave of agentic AI, this really specialist type of thing. And I think we're going to discuss all of that in a little bit here. But, before we do, uh, Kevin, this is a DDN webinar. Most of the people attending for us know kind of who DDN is, but we don't really know who Vultr is and who you are. So can you tell us who you are, what you do, and what is Vultr and why are they special?
Great. Well, one of the reasons why we're special is because we have such wonderful partners like DDN. And with DDN, we couldn't be more excited to pioneer the next generation of cloud infrastructure optimized for delivering AI at scale to the enterprise. Vultr has a 10-year operating history, building and scaling some of the most ambitious workloads on the planet. We are the alternative hyperscaler to the traditional cloud providers like Amazon or Azure or GCP. Most recently, we were recognized by IDC in their MarketScape as being a major contender in the public cloud platform marketplace. We operate over 32 data center regions all around the globe, across all 6 continents, helping you reach 90% of the world's population in between 2 and 40 milliseconds. We offer the global reach of the hyperscalers, all of the security and compliance of the hyperscalers, but at an unmatched price to performance, offering our core cloud infrastructure at anywhere between 50 and 90% cost savings. So same performance, dramatically lower price point. And for enterprises today that are looking to free up capital and free up resources to invest in a new generation of AI native applications, economizing the cost of your cloud infrastructure to free up those resources to invest in AI is really critical. And of course, as a public cloud, we provide all of the core infrastructure that you need to build and deploy all of your cloud native applications and all of your new AI native applications at global scale. That's all of your core cloud compute for delivering your end experience or application to your end users. That also is complemented by core cloud GPU. Vultr is the only cloud provider that's offering access to the top of the line NVIDIA and AMD GPUs at global scale to support all of your AI initiatives. We also offer a host of ancillary services from Kubernetes to databases to all of the networking that you need to build and scale safely and securely all of your cloud native workloads and all of your new AI native workloads around the planet. And the reason why we are excited for this webinar today is because we share a common vision with DDN, which is that we're entering a new 10-year cycle where we need to radically rethink the entire infrastructure landscape to support global deployment of new AI models and initiatives. And we've seen radical changes in the technology landscape before, 10 years just prior. Cloud platforms were brand new. We had to re-architect all of our existing web applications to make them cloud native. And now we need to go one step further and make them AI native, which means rethinking all of our networking, rethinking all of our compute, and most critically in the AI world, rethinking all of our storage so that we can start bringing data safely and securely to GPU clusters to train AI models, and then, very importantly, bring that data safely and securely to fill all of our RAG pipelines and start driving inference at the edge. This is why here
Yeah.
at Vultr, we couldn't be more excited to partner with DDN and the full data intelligence platform to help move data from exascaler to support training workloads to NVIDIA all around the globe to support all of your inference at scale. It's all about enabling a pipeline where here at Vultr, we provide the pipeline for all of your compute infrastructure so you can build and train your models either centrally or in regional hubs. And then, very importantly, take those trained models, help you tune them in region, and then ultimately infer them everywhere where people live and work. And with DDN, most critically, what we can do now with the data intelligence platform is build the data pipeline to bring the data to our GPU clusters, to bring our data to clusters where we're training models, tuning models, and then ultimately deploying models to actually deliver an end application experience to actually infer the model to actually drive the business outcomes that we seek to achieve. And this is
So,
all,
hey,
yes,
Kevin.
yeah,
So I have so many questions already.
all
I
right.
want to ask you if that's okay. So earlier you talked about getting to the lower cost, and we're going to address it, I think, a little bit later in the deck when we start talking about that. But one of the things that I just noticed that if we go back to that mapping of that new cloud real quick here, um, I think that this transition really maps to that AI evolution path that I mentioned earlier, right? We
Mhm.
talked about a little bit about, just LLM clouds were the beginning of this, and you had people doing web app architectures, and obviously, when you get to these GPU clouds that were available starting, very recently, really they
Yep.
came to the forefront in about the last 3 or 4 years. Um, they were well defined. And then all of a sudden, in over the period of a year and a half, it went to, oh no, now we have to get to inference and RAG, and complexity went through the roof. And then it forced some architectural changes. And then now we're at this point where I think you're saying that if you don't massively re-architect how you're thinking about delivering AI as a service or as a hosted offering, it can be a real big challenge. Um, and so I see this as being like very in sync with that, get to that AI native architecture as sooner than later. Is that a correct statement?
100%.
Yeah.
The
Okay.
early market was the easy market because in the early market, it was all just about standing up a very centralized GPU cluster for purposes of training. The complexity comes with actually scaling uh, global
Yeah.
distribution of a trained model to actually deliver a service to the end user, and not just delivering one model, but delivering multiple models, dozens of models, hundreds of models, and continuously updating them. And how do you do that safely and securely, particularly from a data
Yeah.
perspective? It's a vastly different world, and that's where the combination of Vultr and DDN really comes to the fore because it's not just about one singular GPU cluster anymore. It's about
Right.
something inherently much more complex, and that's the complexity that we solve together in helping you build the pipeline for your data and your infrastructure to deliver models at scale.
Sure. And I think one of the things that is as we get more into talking about the scaling here in a little bit, especially around like the data use cases and things like that, one of the things that I've noticed, and I'm gonna call you out on this, I don't think your 10-year number is correct
Okay.
that you mentioned. Yeah, right. Um, I think the 10-year number is actually far too conservative. If I
Mm,
look at the rate of change that has happened in the
yeah.
industry in the last year alone, right? We've gone from inference to RAG pipelines to figuring out vector caching to now how do we get context windows to get big enough so that we can
Yeah.
offload to yet another architecture. So that flexibility and that ability to change out within this framework of an AI native application for both DDN and Vultr, I'll be honest, I think that time frame is vastly compressed now at the rate that innovation is happening. I think
Yeah.
you're within a couple of years, if you don't have something that's flexible, you're already out of date. Forget about
Yeah,
10 years
I
waiting
actually
for this
don't
cycle.
disagree with that. I actually don't disagree with you
Yeah.
there. I mean, we are seeing a radical compression of the timeline. We just completed a survey of over 2,000 senior decision makers across North America and Europe. And what was very, very clear is that there are people that are ahead of the curve in terms of, AI transformation, and then there's people that are falling behind. The cycles are definitely getting compressed. So yeah, our timelines might be a little too conservative here. I'd have to agree with you.
Cool. Okay, so getting back to where we were, I believe, was there. You were about to talk to us about flexibility of a composable infrastructure, I think.
Correct. So
We
at the
kind of
end of the
landed.
day, when you're looking to accelerate the deployment of new AI models, you need to be able to spin up the resources that you need in a completely automated way as part of a pipeline. And this pipeline means that you can continuously innovate, continuously deliver new data sets, new models and new experiences quickly and easily with safety and security and good compliance. And so, what we're pioneering here at Vultr is this whole notion of composable infrastructure. This is something we're very familiar with in the general public cloud world. We do this with, compute resources all day long. We
Mhm.
need to apply those same principles for composability, to the AI world and make it as easy to instrument the automated provisioning GPUs for training, GPUs for inference, the provisioning of the models and all of the associated services, including networking and storage powered by DDN. And we need to make it automatic. We need to make it fast. We need to make it resilient. And we need to be able to make it at global scale. And so this is what we mean by composable infrastructure. It is a requirement to cost efficiently deliver AI models at scale. And again, with the combination of Vultr and DDN, now with Exasalar and now with Infinia, we have the true data intelligence platform to make this a reality for enterprises around the planet.
Sure. Yeah, when a few years ago, NVIDIA itself put out a couple of surveys, and they have them up on their website where they talk about like the state of AI for a certain industry vertical. They had one for financials, they had one for telco, they had one for, I think, life sciences and pharma. And one of the things that they specifically noted, I believe, across all of them, and forgive me that I don't remember where on the NVIDIA website to find these, but you can actually still go grab them. Um, they put in basically that the types of tenants, things that people are looking for that are common across all of these were security, were elasticity, and their term for it, I wish I could remember what it is. It was either flexibility or elasticity. But even as far as a year ago, given this accelerated time frame, they were absolutely talking about that if you cannot scale up and scale down on demand, and if you cannot determine where your data is, keep it secure, then you are going to be disadvantaged. And this was surveys across CEOs, CTOs, engineering managers, et cetera, across all these industries. So it absolutely aligns with that vision and what customers are saying.
Yeah,
Um,
one
I
hundred
think,
percent. And there's two aspects of that too, which is number one, and again, in the early market, you could pretty much forecast um, what you might need in terms of training resources in a centralized facility. How many data science teams do you have? How many models do you want to train? You could basically build a GPU cluster. You can schedule, you can sequence the work, and you can probably make good for that for the initial year where you're experimenting, kicking the tires on different types of AI models and initiatives. But the real problem comes when you're looking to scale and you're looking to deploy, because you can't reasonably forecast where the demand is going to be coming for those new AI services in different regions. You can't forecast perfectly, peaks and valleys in the demand. And you have the traditional problem that you had in the web application world, which is in the production environment, you'd have to plan for peak capacity, and then you plan for peak capacity, and then you'd over provision resources that would be mostly idle most of the time. And GPUs are expensive resources. That does not make any sense. So you need to have the
Yeah,
elasticity. You need to be able to scale up, and you need to scale to zero as well. And it's not just the
yeah,
GPUs, it's also the storage too. It needs to be incredibly elastic and flexible, because at the end of the day, you're not just trying to scale one application, but you're constantly onboarding, new models, testing new models. The new version of DC comes out, you want to test that, potentially swap that out and start leveraging that as a backend LLM for some of your RAG applications. So you need to have the flexibility, the fungibility of resources to be able to deploy these things through an integrated pipeline of compute networking and storage, which is essentially exactly what we do together here with Vultr and DDN.
yeah. So I do want to put a little bit of clarity on your comment about elasticity of the peak. And the reason for it is, let me pop up a quick slide here that might illustrate this a little bit. So in terms of things, when we talk about architecting for peak versus how you get to flexibility with an environment, it's an interesting problem that actually having the flexibility of being able to address a peak can actually wind up saving a customer a tremendous amount of time and resources around. So in this example right here, we have an environment where we've used the DDN data intelligence platform, the EXA portion of it. And compared with a number of other storage vendors, there's so much performance available within this environment that if you architect for the peak moments within an architecture, such as massive parallel data loading of a model into GPUs, getting the prefetch for all these particular things for some inference use cases, et cetera, we can compress that so much that when it comes time to do things such as checkpointing for the learning, we can load faster, get the processing across the existing GPU infrastructure done faster, checkpoint quicker. And so that way, customers don't have to sit there and wait for longer and longer periods of time to actually get to a real outcome, because it saves that GPU time and resource. And so it gives them the flexibility of saying, we can pull back a little bit in order to be elastic for it. It's not the same as saying you must architect for peak. No, you're architecting for peak flexibility
Right.
because we're giving this level of performance. So just a tiny bit of clarity I wanted to throw in there for our audience to make sure we weren't
Yeah, and it's an
throwing that
important
down a
point. I
little too
mean,
much.
it's an important point. I mean, at the end of the day, speed matters, agility
Yeah.
matters, right? And being able to have the burst capacity that you get with Exascaler and DDN is what enables you to train and tune your models faster. And again, speed matters, and having that agility to quickly get that time to market is a source of competitive advantage.
Yeah. Actually, we have a quick note that came in on the chat here. Looks like we have a person asking, how do we justify the cost of a peak capable storage when the workloads aren't always running at peak? So from my perspective, right, and I am coming from the DDN perspective, it'll be a little bit different than maybe than what Vultr it has to say on this, is that it's exactly what's on the slide right here, which is that if you can go ahead and get your time to your final outcome compressed significantly because you have that extra amount of peak load in there, at least initially, then you can see the amount of savings that we're showing there. It's time savings, it's eventual cost per hour of GPU types of savings that go down there. Now, that being said, I think this is probably also where Vultr helps out because they have the ability to make that environment elastic and telemetry.
Right.
I'm assuming you guys have telemetry that can basically look at workload environments and say, hey, maybe for now that you've become more predictable, you can find the right time to squeeze it down or grow it as needed. Is that a
Yeah,
correct statement?
100%. So once you speed the model through training and checkpointing, and then you're looking to enable it for worldwide inference, the key is we scale up and scale down the GPU resources necessary to infer that model. So if, for example, suddenly you see demand spiking, just follow the sun around the planet, all of a sudden Europe wakes up and suddenly, demand starts spiking in Germany, and then it starts spiking in the Netherlands and France, then it starts spiking in the UK. And then as the day goes on, the demand kind of starts dying down, and then America starts waking up, the demand starts growing. So the key is what we do is through our worldwide serverless inference infrastructure, we can spin up your model and enable peak capacity in Germany, and then start cutting down the resources assigned for inference in Germany as Germany's day goes on, and then we can start spinning up associated resources in the United States when the United States starts waking up. And the whole point there is that you always are going to have the on-demand capacity to give you peak performance so that you can have the lowest possible latency for all of your inference requests, but at the same time you're not paying for all the resources when you don't have the demand coming from any given particular region. It's about cost optimizing your compute resources. So you're only really paying for what you need and what you use, yet at the same time, getting peak performance.
Yeah, yeah. I think this becomes very, very interesting when we start talking, especially around scale, right? So we may have customers, and DDN definitely has customers that start relatively small, right? Maybe they do a little bit of an in-house type of work. Then they say, uh-oh, we have some success. We want to grow our AI agenda or AI strategy within a company, and it begins to get bigger and bigger. And with success comes both, again, as we talked about before, complexity and scale. So we get to, we go from the training side, the well-known thing, just, that's super fast speed, pump it in, get those GPUs cranking. And then we get to this big, hairy, there's a term for that out there, but RAG application, right?
Yep.
And our chart here went from a very simple one to suddenly we've got 5 different modules, possibly in different geolocations,
Right.
scaling across the globe, full CI/CD pipelines, complete sets of data services that are associated with it. This is getting really complex.
And this is
Um,
actually the simplified view, mind you.
yeah, yeah, it is. I have one a little bit that's even simpler. But when they start looking at, getting to this elastic environment, and I think going back to the question that was asked earlier, how do you what are the types of considerations when they're driving to the right price performance of elasticity in this environment, right? How do customers actually measure it, or how do you guys measure it? Is it something where you get down to like how consistent is the time to first token for performance, or number of vectors per watt consumed, or what are the types of metrics that people look for when they're taking all this and saying, I need to figure out the right balance of massive scale and complexity versus the reality of the economics of making this work?
Yeah, I mean, at the end of the day, it's all about improving your customer experience, whether that's an actual customer or your employee. And how do you improve the customer experience? Well, it has to be lightning fast. and it has to be relevant. So the time to first token really matters. The amount of tokens you can deliver per second really matters. The ability to deliver maximum tokens per second and the fastest time to first token for tens, hundreds, thousands, tens of thousands of concurrent users worldwide matters. If your time to first
Yeah.
token is super fast and you can deliver massive tokens per second for one user, what happens when you suddenly have 1,000 concurrent users? What happens when you have 10,000 concurrent users? It shouldn't degrade. The time to first token should remain as
Yeah.
constant as possible. The number of tokens per second should remain constant as possible because that end user, that one end user, doesn't know or doesn't care how many people are simultaneously making a request. They just still want that amazing experience, right? So this is
Yeah.
where again the elasticity matters because you've got to be able to handle, the ups and downs of your demand spike, and it needs to be as cost efficient as possible because at the end of the day, what you can't have is you can't have what happened in core cloud compute when people first moved their workloads to the cloud. It was all just rush to the cloud and the cloud will magically make us more efficient and save us a whole bunch of money. But in the early days when people rushed to the cloud, they didn't architect things properly, and they got locked into a whole bunch of ancillary and hidden costs from things like the hyperscalers, and then they wound up not getting any ROI. So what we're
Right.
here at what we're trying to do is we're trying to educate people on how to think about the economics of scaling globally in the most cost efficient manner possible, so that when you do deploy, you not only get that superior performance your customers demand, but you do so in a way that enables you to not break the bank and actually get the ROI you seek to achieve.
Okay, that's fantastic information, Kevin, because I think what I'm hearing here, and I absolutely agree with this, is that getting that consistency across the board is good. But what I heard in there was the little statement, which I think needs to really be surfaced. At the end of the day, the fastest response you can get for a customer is the ultimate measure of customer satisfaction
Correct.
or customer experience at the end. So whether you're doing, having all the infrastructure in place to do that time to first token quicker, the lower latency is fantastic, but having that, but at the end of the day, that final response. So architecting the entire pipeline to give
That's right.
that is really what's going to matter.
100% correct.
Awesome. So, we showed there how the challenges with going from a basic RAG pipeline into potentially scaling to 10,000 or more. We talked about performance, et cetera. So when we do finally talk here about what the underlying infrastructure looks like inside of Vultr, right? If we're going to create a highly idealized environment to get to that perfect customer outcome, one of the things that we have in place here now is the fact that Vultr and DDN work together, and they can offer DDN data services under the cover to power all these things.
Mm-hmm.
And so we have this combination that's available, and I'm going to have you dive into this diagram a little bit more than I'm going to talk about. But there's really two parts to it, right? We can start out with the training side, the ability to get this ultra high throughput, the ability to saturate GPUs on the training side to create incredibly low latency from a file system perspective, whether it's in the cloud, whether it's one of the managed on-prem data stores that are set that Vultr can go to. And that's really the exascaler platform that we have in place for data intelligence. But then there's the second part of it, which is, hey, you've got this data, you've taken the LLM model, you're transitioning it now from, you've created a certain amount of precision and you're moving it off to inference, whether it is just normal inference or it's agentic AI, which is a wildly more complex than this even, right? It's what if you had a RAG pipeline calling another RAG pipeline, doing reversion on it and continuing to update amongst other things, and even specialized models. Then we have something like DDN Infinia. And one of the aspects that Infinia really brings to the table is the idea that if you're going to do things like provide tokenization, provide vector, provide RAG lookups across massive data sets, it gives you this incredible amount of flexibility and incredibly low latency. In fact, some of the measurements we've been doing, uh, both with NVIDIA for things like superpod qualification and pod qualification with them, as well as with our own internal testing that we've had, show that Exascaler in many cases can be up to 16 times faster on data
Amazing.
loads and
Amazing.
checkpointing than even a lot of other parallel file systems that are out there on the market. And Infinia, at the same time, when you have this huge amount of, again, 10,000 concurrent sessions coming into it, of everyone saying, I need to do a RAG lookup, I need to go ahead and pull stuff that maybe isn't cached and so on, we're seeing up to 30% lower latency. So given that additional amount of performance, given the flexibility that both Exa and Infinia can provide, how does that play into this big combined admittedly, our diagrams have been getting more and more complex as we've gone through this webinar.
Yeah.
So how does that play into Vultre's entire view
Yeah.
of these massively concurrent data pipelines?
Yeah, so it's a great question. And, this is an illustrative example of like a real world application. We started off the webinar and you highlighted a variety of different industry use cases. Well, this laser focuses on one, which is, the patient experience, which is, how can you use AI to deliver, better patient outcomes? And it starts first by actually training a model. So in this particular case, you could imagine that a person is going to their healthcare provider for a routine, blood draw to get new lab tests. Well, ultimately, there needs to be an AI model that actually takes all of, your proprietary confidential information and analyzes all of the you know blood test results and all of the associated later symptoms and ailments and healthcare outcomes of patients to build a model to be able to detect you know depending on what the blood test results are, for different things, what might be, suitable things that are, recommendations for treatment or preventative care, right? So there's a big upfront training of a very large confidential data set that needs to happen. But it's not just that one-time training, because at the end of the day, as new blood test results come in, and then later on, as people report new ailments and then later are treated with different therapies and then have specific outcomes, all of that data needs to feed back into the model. And, once a month or once a
Right.
quarter, the model needs to be tuned because, you're constantly learning, new things to discover based on lab test results. So it's a continuous training loop. You're constantly feeding new information back into the model. And to your point earlier, is you want to be able to retrain, to tune that model very, very quickly,
Mhm.
because it suddenly you realize over the past 3 months that a specific change in certain lab work is indicative of a new novel disease, like maybe a coronavirus. You want to tune that model really quickly so you can start
Absolutely.
delivering. You don't want to wait a week, right? That model's got to be
Right.
tuned very quickly and go back out so you can immediately help people get the answers that they need. And again, if you get your lab test results, I'm going to log into the healthcare portal, and I got my lab test results. I get a notification, lab test results are in, and I immediately want to, as a consumer, I want to immediately go to the healthcare portal and I want to basically say, tell me about my lab test results. Okay. If the lab test results are in, I want to immediately ask a question and I want an immediate response because I'm concerned. I want an answer. And so what happens is that lab test result needs to immediately be, pulled into a vector store, as you saw in the previous RAG pipeline slide, and it needs to immediately be available for inference. So that means you need to be able to very, very
Mhm.
quickly serve up that inference request powered on the back end by Infinia storage. Because as a consumer, I want that answer and I want that answer immediately. And that's essentially what we're showing here, which is the entire RAG pipeline for a patient to be able to go into the healthcare portal and interrogate the back end AI model to actually
Right.
get an answer for how to think about their lab test results and what they might need to do in terms of preventative care or what treatment options they might need to discuss with their clinician. And it's not just for the patient itself, there's also the clinician as well. So the clinician also
Yeah.
needs to be
The
able to
researchers.
immediately, the researcher, they need to be able to ask questions
Yeah.
too, like, well, tell me about Kevin Cochran's lab results. They might be certain, they might be helping 1,000 different patients. Do they have the time to analyze every single patient? Well, no, they don't. So you've got to empower them with the productivity tools that they need. And the productivity tools they need is they need to be able to ask an agent and say, tell me what I need to pay attention to in Kevin's lab test results from this month, right? So
Yeah.
again, the power of the data flows and the power of the data intelligence is really critical for very quickly training a model, very quickly being able to tune a model continuously, and then being able to infer a model rapidly to deliver the experience that your consumers demand.
Yeah, and I think, and I love the fact that you used a healthcare total possible data pipeline here because it really does start all the way from lab research, the wet tools that they use in the labs, everything from the centrifuges to the EM, the electron microscopes, right, that they pull together to determine where things are, protein research to disease diagnosis, and then pass that into a database of source that can be queried by the clinician to say, does our local lab result map? And so it's really far more intertwined. And in the
Right.
example you're talking about, a healthcare portal, even a small health agency at a hospital or several hospitals in a group, this can easily be hundreds and hundreds of queries at any given time. Given unfortunately in some cases how busy hospitals are. So that's a fantastic example of the entire end-to-end pipeline, how it actually gets bigger than you would expect. In fact, one thing I'd like to highlight is that in some cases that lab work may not be in the same location, right?
Correct.
Many times they will outsource, and so you may have to have someone who says, I am overnighting certain results off to the lab that is in another state, and then they bring it back. And so you may actually have this entire type of pipeline or how they talk to each other distributed
That's right.
geographically across multiple areas as well.
That's correct.
Um, hey, so it looks like we have another question coming in. So the question is, RAG workloads often get bogged down by data movement and search delays. How is DDN going to help speed that up in this Vultr deployment? Yeah, so I'll take that one. As I mentioned before, both the DDN data intelligence platform sets that we have in here really are geared towards getting the fastest response at the lowest latency back to all the compute resources and all the data resources that are available inside of this Vultr environment. And so let's think about this in two different ways. The first one is from a core infrastructure standpoint. We already talked about things such as Exascaler being able to give you really fast training results, back 16x the performance. Would you like to have a terabyte a second of GPU data loading time? 2 terabytes a second, 5 terabytes, it doesn't matter. We can scale it up. Vultr can automate that scaling. That's not a problem. When we go from that end to the inference side in a RAG workload, one of the biggest challenges that we've seen is that when someone updates a RAG environment, you're constantly loading new data to be queried so that your original LLM that's being deployed and is being asked for says, I don't have enough information. I need to generate a vector and a token that says, please go find more information out of a vector database, out of the actual whatever assets have been tokenized, and Infinia will store all that. Now, one of the things Infinia is really well known for is incredibly low latency. So if you think about the data round trip time, we start with the query coming in from the portal. It goes into this query agent, which then says, talks to the LLM with and posits the question and tokenizes the question for it, right? The LLM then says, hang on, let me pre-process, figure this out. I don't know enough. It then sends it across. And so you have all these different types of data movement that potentially can happen. So achieving the lowest amount of latency in order to pull the correct tokens out of a vector database, out of the actual tokenized documentation or tokenized set of data that the LLM can read and add to its response as it's doing this intelligent type of response, that's where it really matters. And so Infinia, incredibly low latency in terms of what it brings. It's sub-millisecond consistently, even across hundreds, thousands, and tens of thousands of requests coming into it at any given time. And so that right there is really how it helps speed up getting that data response back, so that those saturated GPUs that are in place can respond as quickly as possible. And of course, if there's anywhere in there that seems to be a bottleneck, Vultr, what really helps it out is that they can go ahead and elastically scale as they detect that a certain area is basically being bottlenecked.
Exactly.
Cool. I got it right, I think.
That was awesome.
Yeah. Thank you. So Kevin, at this point, I think we are beginning to run on time. So I want to thank everyone here for attending this webinar. We are going to try and stick around for a few minutes after this. So if any final questions come in, we'll try and answer them on the fly. If not, because you registered to come to this webinar, we will try and get an answer back to you as quickly as we can. For more information on everything that we talked about, please visit ddn.com or vultr.com. And as you can see, it's Vultr minus the E at the end. So make sure you get to the correct one. And with that, Kevin, thank you so much for bringing a really great perspective on the role of LLMs, the role of Vultr and DDN working together to help, as you said, create a great customer experience. I'm sure you and I will have plenty of other topics in the future to discuss as we need to.
Thank you so much for having me, Joel. Look forward to continuing the conversation with you in future webinars.
Fantastic. With that, we're signing off. Thanks, everyone. Have a great day.